Hello everyone. Today is 14th of February 2019. This is my third episode about C++ type function, modern C++ programming. In this episode, we will learn about template parameter. We will learn how to remove constant and reference from a type, how to extract template parameter type from a template class, how to test if a type is a template class, template class basic syntax, and forwarding reference or universal reference, variadic template parameter expansion. All these concepts are interrelated, used together in modern C++ programming. Precompiled header and response file for Microsoft C++ compiler and GNU G++. This video is my previous video. From my previous video, please download our previous source code. When download is complete, show in folder, unzip it, and copy the folder, copy, and paste it to your working folder. Double click the folder path. In your command prompt, properties, set the folder path, starting folder path, click OK. Now start Visual Studio Code, file, open folder, paste the folder path, enter, select folder. Select the folder, make folder, all three, template, enter. In this folder, select this folder, we will create pch one file and another file pch cpp and another file template cpp. We created three files. Open pch, this header file, include talk play fun, type utilh, and in pch file, in this file, include pch, then in template file, include pch, and save all. Here, right click, not this file, right click, copy and paste. Then this file, rename it pch local, like this, enter. When this pch local is selected, remove this part, fix like this. Okay. Also in MSVC this file, right click, copy and paste. Select this file. Then here also modify like this. Okay. Then rename this file msvc underscore local, like this. Now save all and close all. There is no closure. Right click. This template CP, right click, close others. Then here int main, we will create in global scope auto stream talk play fun stream like this. Stream hello. In the command line, dir cd o3 template. Okay, we are in this folder. cl, we are compiling precompiled header like this. pch local pch cpp. Okay, we are creating precompiled header like this. Then msvc local template cpp. Okay, m is created like this. M is running. Now auto nl stream get console out like this. Then we can now use nl. Now we will create a template class. Template type name, type name, types. These are called template parameter. Then auto build vector type first types args. We build a vector std vector type b first args. Then we return vector void test build vector auto b build vector. We are calling this function like this: 1 2 3 4 5 elements. Then we display stream b equals b nl. We are calling this function. Then test build vector like this. Now we are building this function. We are testing this build vector function like this. Okay, built successfully m. So vector b is built successfully like this. This parameter type args is called variadic template argument. In this case, please remember the syntax. Type name types is called variadic template parameter. So this is template parameter, and this is function call parameter or argument. Argument is used a little bit different way. In old days, parameter and argument were interchangeable. But now, in modern C++ programming, parameter and arguments are different concepts. So this is more correctly, this is called function call parameter. Argument is incorrect in modern C++ programming. Type ARG is called variadic template function call parameter, and type name type is called variadic template parameter. So all in this case, this is parameter, type parameter, this is function call parameter. Now we call this parameter. So in this case, 1, 2, 3, 4, 5 are arguments. 1, 2, 3, 4, 5 are called arguments. It is actually identical, or B build vector. Say we have 5 integers. It is like this: int, 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 1, 2, 3, 4, 5 ints, 1, 2, 3, 4, 5. Now in this case, this int are called type arguments. Because int are types, these are now called type arguments. So argument and parameter are a little bit different concept in modern C++ programming. Now let's build once again. Okay, it works perfectly. In this approach, there is one drawback, because this build vector always returns container of vector. Okay, so we want to change this container type, then we need another construct like this. Template. Now we are passing template, type name, class, container, type, like this. This is our first parameter. This is a single parameter. This is called template parameter. Okay, then type name, type name, types, like this. Then we can still use auto, like this. Build container basic, like this. I named like this. Then type first types args like this. Then we can use this type container, okay, like this. Container type, we are passing parameter type, this type, then C is container, first args, we are expanding variadic template parameter like this. Then we return C. Now we will test this function. I will rearrange a little bit. Void test build container basic like this. Now when we call this function, these parameters can be deduced from parameter, but we have to provide this container like this. Auto b build container basic, we have to provide container like this, std vector or dq, okay. Then we provide parameter 1, 2, 3, 4, 5. Please note that we have to provide argument. This is called this std, dq is called template argument. Okay, because this is argument and this is parameter. So with this we can display like this, as stream b and l like this. Now we test this function, copy, paste. Now let's build. Okay, it works like this. In build container basic, this function still has one drawback. This function has one drawback. In C++ programming, non-reference parameter gets type decayed. The argument type is distorted while passing as argument. For example, I will create here a function, template, type name t, void print type ta, stream, type of a, talk, play, fun, get type category a, std and void test print type function. We are testing this function like this, inta 5 int reference l value ref a. Okay, we are calling this function print type l value ref. we are passing L value reference to print type. Now let's test this function. In command line again, we have to fix it to NL like this. I fixed. Now let's build and run. So the type of A is int. Please note that we passed reference, L value reference to this print function, but the type of A parameter or argument A is int. Even though we passed the reference, the type becomes modified. To address this issue, we can try like this. Constant reference, but still, if we modify like this, now it becomes constant reference. Or if we modify like this, it still seems to be working. It is int, but this does not work. Print type 5. Now it does not work. Let's try it. Now it does not work. If you want this function call and this function call, both function calls succeed, you have to prepend the constant here. Then it works. Then it works as expected. But there is one big problem in this approach. This is a typical pre-C++ 11 standard programming style. As you can see, this is R value, pure R value, this is L value. In this function, the passed argument 5 and L value ref is totally distorted. The biggest drawback of this approach is that the passed arguments type is distorted. To address this issue, C++ 11 standard introduced forwarding reference. Now I will modify it. Template, type name, type, void, forwarding reference. Now we modify like this, or we can just say T. A. Now we print out stream. The type of A we can use like this. talk play fun, get type category A, NL. We can also print out the type of T, stream, the type of T, talk play fun, get type name, T, and L. Now we test this function, void test forwarding reference, int a, int l value reference a, int r value reference 10. We are calling this function like this. I will say here constant character msg stream msg ml like this, forwarding reference with int a, forwarding reference with l value reference, l value reference, forwarding reference with r value reference, r value reference, forwarding reference with pure r value 5, I would say 20. I will call one more here, forwarding reference with std forward int a, I will copy like this with std forward int std forward int I will copy this part once again, std forward int std forward int now let's test this function, copied, paste, I will make a few more changes, std forward int a, and I will copy one more line. I copy and paste it like this, Then let's build. M. So if you compare with this result and these function calls and how parameter A and T gets modified, when we pass a local value A, in this case, this line of code, A is L value reference. In this case, T is L value reference. But when we forward A with this syntax, A becomes R value reference in this function. T is int. In this case, L value reference. In this function, T is int, A is int, L value reference, T is L value reference. When we forward, in this case, A is still L value reference, T is L value reference. In this case, R value reference, A is L value reference, in this function, even though we passed R value reference, T is L value reference. So watch this line carefully. In this case, when we forward int R value like this syntax, with this syntax, this line, A is R value reference. Here, A is R value reference with this syntax. And T is int. With this syntax, when we forward R value like this, A is R value reference in this function, and T is int. And lastly, in this case, A is R value reference in this function. Type of T is int. I will talk more about std forward and R value reference and L value reference. One thing you should need to remember is that in this function, forwarding reference function, T can be L value reference or just int. The type of T changes. In this case, it's int. The type of T changes. Okay. In this case, L value reference. In this case, not reference. So the type of T can be either L value reference or non-reference type. And the type of argument A is always either L value reference or R value reference. Okay, I will summarize it here. In case of forwarding reference, the type of T is either L value reference or non-reference type. The type function called parameter A, its type is either L value reference or R value reference. Remembering these two things, 1, 2 is very important. Also, another thing you should remember is when this local variable A int is passed just as A like this in this syntax, it is L value reference in this function. And when it is forwarded like this int A, the type of A is R value reference and the type of T is int. Another thing is type of t and the type of function called parameter a can be different. Another thing very important is when you pass r-value reference like this, both a and t are l-value reference. It is not forwarded. It is not forwarded like this. When r-value reference is passed without forwarding, the type of t is l-value reference and the type of function called parameter is l-value reference. Okay, so we passed r-value reference here. We passed r-value reference. In this function, in this case, both l-value reference. If we forward it either this syntax or this syntax, the type of A is r-value reference, the type of A is non-reference type. Actually, you do not need to remember all these things. Practically, all you need to remember is that both the type of t and type of function called parameter can be changed depending on parameter passing method. We can control the type of the passed parameter either using std forward or std move. I will talk more about this in some future sessions, in next session probably. In this session, please remember just one thing. In forwarding reference, the type of t is not non-reference type. It can be l-value reference type as well. About these things, forwarding reference and std forward and std move, I will talk in my next session. Now we understand this function is not good enough because this can distort type of the first and type of arguments, args. So I will modify it, I will copy it, and we will change the function parameters. Here I paste it, and now I will modify build container advanced. So I change the parameter like this. Okay, in both cases. And I also need to use std forward here. Then I will use std forward type, and I fix like this. Also here std forward types, I modify like this. Actually, this is not yet perfect, but we will fix very soon. Now test this function. I will copy this function. I copied and paste it here. Test build container advanced, and we are calling this function. I copy, pasted, and I will change like this. Okay, let's call this function test advanced. And here we build again and run. It runs successfully. Now let's test once again. I copied test build container advanced, I say failed. Okay, now I put another thing, int a1. Now I pass it a here like this. Okay, now I call this function, copy, paste, I disable this, then compile again. Voila, it doesn't work. I will show you the message again. This is saying some messages, hard to read message. It basically means it is not possible, because in this case a, we are calling this function, it does not work because of the type. Okay, in this case it worked. It works, but it does not work. The reason is this type. Okay, so I will disable it, and I will also disable this part, and I will disable this part. We also have to disable it like this. I fixed. Now we can call this function, and it does not work. How can I test it? I will disable it here. Instead, stream type talk play fun, get type name, type std nl and stream type of first, talk play fun, get type category first, nl. So here we put message like this, stream calling with 1 2 3 4 5, nl. Here I will copy this code, calling with a, like this. Then we display, we enable both function. I enable the both. Now we compile and run. Now we compare. Say when we called this function 1 2 3 4 5, the type of t is int. When we called with this parameter, the type of this type is int. So this works. Container type int works. But when we call it with this syntax a 2 3 4 5, this type becomes integer reference, L-value reference. So it does not work. So when we call this with a L-value reference, the type of this type becomes integer reference. in C++, we cannot hold reference type in the container class. So this does not work. We have to remove reference. This reference, okay? So I will remove reference. I will disable this part and I will re-enable it. Here I'll remove reference like this. std remove reference t type. I remove reference from type. I fixed like this. Then return C. I fixed. Then here also. Now both works. Auto B. Now it works. I will make it alive like this. And here auto B. Now I fixed both like this with this std remove reference t with modifying like this. Now it should work. What's the problem? Okay, I think I made typo. So let's build. And now both case works successfully. Calling with 1, 2, 3, 4, 5, it works. Calling with A 2, 3, 4, 5, it works. But let's modify once again. Here. I say constant. I added the constant. Let's build. It doesn't work because it becomes constant. In this case, when we pass with this modify like this, then this type becomes constant. So we have to remove once again. std remove constant t. Okay, we have to remove like this. Then we have to do once again. We have to fix like this. Okay, now let's build once again. Wow, it works perfectly. So we have to fix like this, and because we are using this function quite a lot, we can do like this using type t. I will copy this part. I copied, cut, and paste it here. Then in this place we can put type t. Okay, I modified like this. Then it works perfectly. Okay, please note that it does not work using type t. I go in reverse order. I will go in reverse order like this. I copied and pasted it here. I put it inside like this. I copy. I modified like this. Okay. I will disable it. This does not work. I will show you. It does not work. Okay. So it does not work. When you remove reference and the constant, you have to remove reference first, so it does not work. Now it works. So don't forget this point. Okay, it works perfectly. Because we are using this syntax quite a lot, we use quite a lot this syntax. I copied and I will put it here at the top of our function. I paste it, then I introduce template, type name, type, and we can say instead of doing this, remove constant reference t. I named this. Now copy, scroll down here. You can do like this. Instead of this, paste, type. Now everything works perfectly. Okay. I have another thing very important to tell you. This session become too long. I will see you in my next session. In my next session, I will talk about std forward and std move. Thank you for watching.